Welcome to Geometry 2.2, Definitions and Biconditional Statements. Alright, so let's review. What we're talking about is this is the proofs part of geometry, that we're being lawyers, and we have to learn what I call writing haiku poetry. It is just a certain way you have to say certain things, and it doesn't matter if it's true or not. Now, this section of the book, 2.2, the book struggles a little bit because for the haiku poetry part, it doesn't matter if it's true or not. But where we're moving to in math, it does matter if it's true or not. So the book's a little conflicted. It'll say this needs to be true, and then it says, no, it's not true. So you'll see what I mean when we get there. All right, so first we're going to review a word that you might or might not know, and it's perpendicular. Perpendicular means crossed, like the plus sign. Perfect 90-degree angles between it. So if you have two lines, they have 90-degree angles. The symbol for perpendicular is that little square looking thing in the corner. It's usually written in red, but it doesn't have to be red. So if you see that symbol, it means the lines are perpendicular. You don't have to prove it. And that would be considered okay for a given. I know those words didn't make sense to you. That's okay, we're getting there. We're going to proof land. Okay, so another symbol for perpendicular lines is just writing that symbol right there. Sometimes you'll see just that, and it means that lines are perpendicular. And then also, you can have a line that's perpendicular to a plane. Think of a pencil stuck through a piece of paper at 90-degree angles. That's easy, right? Not bad. So here I have drawn two perpendicular lines, line AC and DB. They meet at point X, and we have the symbol for perpendicular right there. So the first question is, are points DXB collinear? DXB. They are. So yes, they are. And then, is AC perpendicular to DB? And yes, it is, and we know that because of the definition of perpendicular and the symbol. And then the next question is angle AXB adjacent to angle CXD? So angle AXB is that one. Look, we'll color it green because we're not coming back here. It's that angle right in there, adjacent to angle CXD. All right, so there's it colored green too. So is it? The answer is no. Okay, but let's review some things that I want you to learn from this. One is, notice how I wrote that in symbols. In geometry, it is perfectly okay to use abbreviations and symbols whenever you want. So instead of writing the words line AC, this little line on top with arrows on both sides mean line. Over here, that is line segment. This is line segment AB, not the same. So as long as you draw your symbols correctly, you're welcome to use them. Another thing I was going to tell you is, what does that word adjacent mean? It means next to. So a lot of times you'll hear it in regular English, the lot adjacent to CVS is empty. And that means the piece of land next to CVS is empty. All right, so are these two adjacent? By definition, no, they're not, because they would have to share a line, and they don't. Another thing is, if you're writing the symbol for angles, you can do the angle symbol, but you have to write the letters in order with the vertex in the middle. So AX is the vertex B. AXB is this angle. You can also call it angle BXA, but you can't call it angle XAB. Yeah, and one time I had a student not understand this about the ordering of the letters. He thought you had to put them in alphabetical order. No, you put them in order of the shape. Okay? Things like that. He didn't know. It was a good idea. It was just wrong. All right. The next idea is we're going to review a conditional statement, what we learned last time. It is Saturday. only if I'm working at the restaurant. So this one is a little different than what we learned last time. Last time we would have said it, if it is Saturday, then I am working at the restaurant. So this is just showing you that there is another way to write it. It is Saturday only if. So you don't put the if there and you don't put then here. Instead you say only if I'm working at the restaurant. So this is the hypothesis, that's the A, this is the B, that's the conclusion. Okay, so now there is another kind of statement called a biconditional statement. And it has the phrase if and only if in it. So 3 lines are coplanar if and only if they lie in the same plane. If, this is where it gets tricky about what's true and not. The book says it is a biconditional statement whether it's true or not if it contains the phrase if and only if. The book also says that biconditional statements have to be true both ways. So they're talking out of both sides of their mouth. Eventually we're moving to truth, so it doesn't really matter. It would matter more if you were taking a logic class just to follow. But just know that we're going to say it's true both ways, but later we're going to see one that's not true both ways. Okay, so it's got this phrase, if and only if. Now we use that phrase in the South. We'll say, Mister, you are not you are going to the skating rink if and only if all your chores are done. What that means is your mom is saying with emphasis, you better get your chores done if you think you are going to the skating rink. Got it? So we use this in our speech to be a really strong statement. Just like that, in math, biconditional statements are really strong. Okay? So the way to abbreviate if and only if is if. IFF. If. So you can abbreviate that, IFF. Okay? So if it is a biconditional statement, you should be able to say it the other way and it be true also. So this one would be if 3 lines, or we shouldn't say if, 3 lines, when 3 lines lie in the same plane, if and only if they are coplanar, something like that. And so the condition, this is equal to writing the condition and the converse at the same time. If you remember, converse is you do B then A. So you are doing, it's sort of considered extra strong, extra heavy. All right, so here's one, a biconditional statement. X equals 3 if and only if x squared equals 9. Is it biconditional? Yes. Is it true that x equals 3 if and only if x squared equals 9? Well, 3 squared is 9, so that seems true too. Okay, so now let's, let me look at this, make sure I'm not, that they don't want us. Oh, okay. Okay, so the book says that it's biconditional because it says if and only if. But if we did the converse, would the converse be true? It would be x squared equals 9 if and only if x equals 3. And that is not true because it could also be x equals negative 3. So is it biconditional? The book says yes, just because it said if and only if. Is it true both ways? No, because if you flip it, it's not true. So we're not really going to worry about true right now, okay? Don't worry about true. Just know that biconditional is if and only if. All right, so let's do another one. If a number ends in 0, then the number is divisible by 5. So if we were going to say this is a biconditional statement, it would say a number ends in 0 if and only if the number is divisible by 5. That would be true, but is the converse true? If a number is divisible by 5, then it ends in a 0. No, because it could end in 5, right? Let's try this one. If B lies between A and C, then AB plus BC is AC. We're talking about this number line. If B lies between A and C, then AB plus BC is AC. Do you see that? Okay, so now let's write it as a biconditional statement. B lies between A and C if and only if AB plus BC is AC. See, that wasn't hard. And now let's see if it works the other way. If AB plus BC is AC, then B lies between A and C. That one's true both ways. We made it biconditional, and it is true both the conditional statement and its converse. All right? So this isn't too bad. Just take your time, get in a quiet place to do it so you don't get confused, and you'll be great. Math is fun.